first must correct my distinguished colleague and friend, Dr. Professor Noss, who thought he was the last person standing between the crowd and the bar. That is my unhappy role. But let me try to keep it brief. As last night, I'll divide my remarks into 4 short sections. The first are 2 framing quotations. George has to write a report, I think, for the Social Sciences and Research Council, so I want to increase the Canadian content a little bit tonight in what I say. But the first framing quote is international. It's from the Spanish-American philosopher George Santayana, and it is the famous observation that those of us who do not remember history are condemned to repeat it. I'll come back to that a little bit later. The second quote is Canadian. It comes from the late distinguished literary critic from the University of Toronto, Northrop Frye. Frye was an interesting chap. He, up to a point, really liked mathematics, and he particularly liked mathematicians' passion for their subject. But then when someone informed him that the pair of symbols, as in 7 exclamation mark, was not an indication that mathematicians looked at that number and thought, wow, it was a rather more mechanical thing. That's when he lost his feel for mathematics. But he did go on to say in a couple of different settings, one, the uses of the imagination, another talking about art, and also about education, that it was important at all times, if you were an intellectual, to think about 2 different worlds. And the one world was the world that you actually live in, and the other world was the world that you wanted to live in. And I think that that's a very powerful way of looking at things in situations like the ones we find ourselves in. Let me move to a second section of my short comments, which has to do with sort of cultural aspects of things. And I'll deal here with 2 parts. The first is cultural, historical, social, and the second has to do with our speakers. I think there's something about, and this is my intimate outsider thing again, I have spent a lot of my life studying and being on sabbatical and traveling in England. I have a very high regard for the English way of life, English history, etc. And I think if you thought about the idea of coding generally, you could not find another culture which was more sort of predisposed to deal with issues of coding. It might not always have the happiest social context. It may have to do with different class structures and wanting to keep secrets and so forth. But if you think, for example, of scholars like Lewis Carroll, who was a mathematician, remember Alice in Wonderland and so forth, and that people are still trying to unpack a lot of that coding of a particular sort. I'm particularly interested in coding as it relates to the history of the 20th century and the role played by code breakers in the First and in the Second World War in the United Kingdom. And the interesting thing is that there was a great change in the code breakers between the First World War and the Second World War. And in the First World War, they were linguists. And in the Second World War, they were mathematicians. Okay, and as a sort of side Canadian note here, almost everyone now knows the amazing story of Alan Turing and the breaking of the Enigma code. Almost no one knows of the even more significant achievement of a gentle, quiet man who served as a professor of mathematics not more than 100 kilometers from here for the last 40 years of his career, a man called Bill Tuck. And he cracked the really tough code. Turing and his team had lots of help. The Poles had given the French a lot of information about the Enigma machine. The French had passed that on to the British. They actually had an Enigma machine. Tuck didn't have a machine. He had been a member of the Trinity Mathematics Club as an undergraduate a few years before, and he used that experience to crack the major German high command, only 26 machines. And nobody knew about that because the secrecy was maintained extremely tightly for a long time. So that's the culture we're coming out of. And so you might begin to think that if we want to look at a place where very interesting things about coding might happen, I think it would have been wise to look at the United Kingdom. And then I want to shift to our distinguished visitor friends here. I think that speculation about England in particular being a very good place to look is well-founded. And there's some social and personal things that have happened there, which I am incredibly impressed by. Partly I'm impressed by it because these are people who have been very good to me for many years in many different contexts. And they are, they are extremely kind and extremely capable and all those sorts of good things. The surprising thing is that a lot of that capability and hard work and professionalism has been recognized. And so when you look around the world at the relationship between mathematicians and mathematics educators, it's often pretty strained. If you're lucky, it's sort of tepid, and if you're unlucky, as in the west coast of the United States, it's awful. You think of the experience of Joe Bowler at Stanford, for example, in the math wars. In the United Kingdom, and in particular, in the person of Celia Hoyles, quite amazing things have happened. We have had a mathematics educator working cooperatively at the highest levels with the best mathematicians in the country. And that is quite astounding. We all know the phrase that behind every successful woman there's a man, and that consort in this case is Richard, and this is very true. So for a period of close to 30 years now, they have been relatively quietly, but helping international students, organizing international meetings, traveling broadly, and just doing terrific stuff. I'm very excited to see what's going to happen with Scratch here. And so a public thank you to Richard and Celia for that work. Section 3. Some aspects from the presentation that caught my attention tonight. The world we live in. The world we live in, isn't it interesting that Mr. Schmidt goes to visit Mr. Cameron and all of a sudden the curriculum changes dramatically. The 1% speak, the 1/10 of 1% speak. And this is the nature of the world we live in. Other things, in some ways the British experience is not, the English experience is not going to be very useful to us because they have been in the situation where they have an existing curriculum and they still have a curriculum, but there's been a lot of change. We are not in that situation, okay? It's quite different. So the questions that we have to answer are in some ways rather different questions, although I think we have a great deal to learn from the experience of Richard and Celia and their colleagues. I very much like the exercise of versions of a circle and Richard's later comment, the circles that Celia and I move in. I couldn't decide which program they used when they moved. I was delighted to see the reference to turtle geometry, one of my favorite books. One aspect of that, my experience that I particularly liked was to go into a very genteel bookstore. It was University Press Books in Berkeley, California, and asked for a copy of Turtle Geometry, and the charming sales lady said, "We don't have that, but I could give you Bumblebee Economics," which was true, by the way. I think Packard's last comments around the 10% of what counts in the mathematics curriculum, very rich, very important for us to grapple with. Celia's an optimist. It's one of the reasons people like working with her. She listed a lot of things why we will do better this time. I agree with her on almost everything she said. I said some of them last night myself. There's more personal devices, there's different modalities, online resources, etc. My impression is that the world is a much more complex place now than it was when we started about 30 years ago. I look at the pressures on young couples. I look at the pressures on my students who have graduated in recent years, and not just, fossils like myself, but, younger people in their 50s. Their experience is so different from the experience of the people in the 30s raising children. We cannot ignore this, okay? We do so at our peril, I think. I love the multicultural element. One of the reasons I think that London, perhaps in particular, is such a good model for places like Toronto is the wonderful multicultural elements. Coding is not just about computers, folks, okay? Coding is about communication, and the real coding that goes on across the world is really around humans interacting. And personally, I'm not all that happy about shifting the emphasis on coding always towards screens. Okay, I think we really need to think about coding communication between humans. You know, let's not forget that. But I think one of the places where we will get our best reception to exercises in coding is from settings where people already have experience in coding across cultures. So I'm not surprised to find that your exemplar was a young Muslim woman. I would think that that would not be uncommon. Let me finish with some challenges. Again, with Canadian content at the end here. These are tough challenges, I think. Again, I think we need here to unpack this relationship between computation and mathematics. To me, I get very unhappy to think that somehow this is a retrograde step. I think my colleague, Professor Whiteley, somebody who worked closely with him at York, may also not be very happy about losing our hard struggle towards visualization and the geometric and so forth. 100 years ago plus, maybe, Russell and Whitehead had reduced mathematics to logic. And we've struggled so hard to move past that, out of it. And now it seems to me we're somehow, perhaps I'm wrong, but I'd like to enter into a debate with people on that one. Let's look at Santayana in terms of, you know, repeating history. Celia made the comment last night after Professor Kafai's presentation about what happened to Hennigan documents and so on. And I think this is generally true. So here's a challenge to you in the Santayana sense. Can you identify an educational institution from a previous time and outline what we have to learn from it? Are educational innovations always doomed to sort of peter out? I have a candidate, but this is not the time to elaborate on it. Last two comments, both Canadian. I think I would make as mandatory reading. I no longer have that privilege. Stephen Kahn was one of the last people to suffer from it, but I would highly recommend a book written in Canada in 1969 called Technology and Empire. It's by a man called George Grant, and he said in that book at one point, we can hold in our minds the enormous benefits of technological society, but we cannot so easily hold the ways it may have deprived us, because technique is ourselves. It is difficult to think whether we are deprived of anything essential to our happiness just because the coming to be of technological society has stripped us above all of the very systems of meaning which disclose the highest purposes of man. Whoa, 1969. And because this conference, this series of conferences has always had as a highlight the crossing of frontiers, and in particular the arts and the sciences and mathematics, let me take as my final challenge to you an observation made by that distinguished mathematics educator, Margaret Atwood, writing in 2008 on the Massey lectures, and Ms. Atwood was in a rather strange domain for her. She was talking about economics, some of you may remember it. And she says, very close to the end of that book, in the non-fictional world in which you and I do something called existing, what a lovely phrase, in the non-fictional world in which you and I do something called existing, and Scrooge does not, we've been discussing various ways of looking at debt. Like all our financial arrangements and like all our rules of moral conduct, in fact, like language itself, notions about debt form part of the elaborate imaginative construct that is human society. What is true of each part of that mental construct is also true of debt in all its many variations, because it is a mental construct. How we think about it changes how it works. Maybe it's time for us to think differently. Maybe we need to count things and add things up and measure things in a different way. In fact, maybe we need to count and weigh and measure different things altogether. Maybe we need to calculate the real costs of how we've been living and of the natural resources we have been taking out of the biosphere? Is this likely to happen? Like the spirit of Earth Day's futures, my best offer is maybe. So, doctoral comprehensive question. Respond to Ms. Atwood's observation that in some fundamental way we need a different sort of mathematics. Is this similar to Patrick's 10%? Possibly, but I'll leave you to discuss that over drinks. Thank you for your attention.